Now for our next couple of examples that will illustrate guidelines 3 and 4, we're going to look at radicands that contain more than one factor. And all we have to do is to treat each factor as though it were a problem by itself. So our first example is the square root of 72 x to the 14th y cubed z to the 11th. Now if we look at 72, we want to look for or find a factor of 72 that's a perfect square, and we would like the largest perfect square factor, and that will be 36. We can rewrite then 72 as 36 times 2. Now x to the 14th already is a perfect square because that power is divisible by 2, so we leave that alone. And the y to the third is not in simple form because the power in y is larger than the index 2. So we want to rewrite that so that we have a perfect square power, and I think you'll agree we can rewrite this as y squared then times y. And for z to the 11th, we would like the largest perfect square factor of z to the 11th, so that would be a power in z that's divisible by 2. And that would turn out to be then z to the 10th, so we have z to the 10th then times z. So now what I'm going to do next is let's underline those factors that are perfect squares, which would be then the 36, the x to the 14th, y squared, and z to the 10th. And what I'm going to do next is to rewrite those factors inside with all of the perfect squares at the front. So then we will have 36, x to the 14th, y squared, and then z to the 10th. And what we have then left would be then 2yz. So now if we rewrite using the product property, we're going to put all of the perfect square factors inside the same radical. So we'll then have 36 x to the 14th, y squared, z to the 10th, then times the square root of 2 yz. So now we can take the square roots of each of the factors in that first radical, and I hope you'll agree that this will turn into 6 x to the 7th y, z to the 5th, and then we're left then with the square root of 2yz.